now I'm going to invite our next speaker, who is a return speaker to BSidesTLV. Our next speaker is Omri Misgav. Omri is the CTO. Yes, you can join me here, 2 meters apart. We're socially distanced. Omri is the CTO of the Security Threat Research Group at Fortinet, and he's focused on operating system OS internals. Now, he's spoken BSidesTLV before, but now he's going to talk to us about some very clever, some very creative criminals who want to get into his whitelist. Let's welcome Omri to the BSidesTLV stage, everyone.
Hi, everyone. So first thing first, cheers.
Disinfectant.
Thank you. Okay, good morning. I'm very happy to be here. My name is Omri, as Karen introduced me. I won't do the introductions again. The research I'm going to talk about today that we did was led by Rotem, our malware research team lead. He's here in the crowd, and you can also find him in the booth, in our booth today. So if you can feel free later on to give him a high five for the great work. Today I'm going to talk to you about an interesting case we had earlier this year when basically cyber criminals decided to hand us their malware and ask us very nicely to remove our detection from it because it bothered them. We'll talk about what we investigated, how they approached us, and everything we found later on, which eventually led us to discover malware delivery infrastructure, which is written in Golang. So at least regarding the conference agenda today, somebody really knew what he did with the timing. But before we begin, just one warning. As I compiled the slides, I realized I'm really, really bad graphic designer. So be prepared. We preferred to put our money for the ice cream that we give out in our booth. So feel free to grab a scoop later on. I think it's a much better allocation of our resources than using graphic designer. So let's begin. So you can see here we got an email that we got. It was on February. The email was sent to the CEO and CTO of the company, Ken and Michael, and a few other C-level executives. If we go over it briefly, so I'll read it really quickly. I was referred to Ken by Ted Kim, no idea who it is, and advised that this team could help with an urgent issue we have at our company. We are suffering from a false positive on our application update, and it's hurting our business heavily. You're finding a false positive in our software, states as such and such. How can we work together so we can get whitelisted for the future and avoid false positives, so our company image and a user, and that our company image won't hurt, and we have further installations. You can find the download here, the link to download here. Just take it. We also ran it in VT, and you can see that we are not bluffing, pretty much. And well, that concluded. So we had no idea who the sender was. Again, we had no idea who is this Ted Kim that referred to us. But you can see all the grammar mistakes, uppercase, lowercase, and extra spacing all over the place. So we decided to start having a look. First thing we did was doing forensics on the email message. We checked the structure. There wasn't any extra data, any hidden attachments or whatever. And the text of the link was the same as the address. So nobody tried to play with us. Next, we looked at the headers, the SMTP headers, to see from where the email came from. Everything was checked out. All the servers on the way seemed trusted, well-known. no signature was messed with, the data wasn't changed during transit, but it did came from a custom mailing app, which wasn't really familiar. So now we had to decide what to do next. Well, we kind of clicked the link, as one would expect. We reached the site that promised us good money without doing anything, which is also always sounds like a great promise. Why not, actually? And then we started looking for the same link that we were sent, but we didn't find it. Instead, we could see that the download link that you can see here led to a different URL. The files that we got were in totally different sizes, and significantly different sizes. When we started looking at them, we saw that they have different icons. They were totally different software. One was in the file that we got was in Golang, and from the file we got from the website was an NSys installer for a Node.js application. And both of the files were signed by the same certificate. So when we moved forward, we started looking at the signatures to see if this file was somehow altered or whatnot. Even though you see that the certificate isn't valid, it was because it was revoked. But for at least a certain period of time, it was valid. As we can see, the original on the right, the file we got from the site, the official installer, as we call it, was signed with a timestamp. So it means that somebody else validated the signature when the file was created. And another thing that popped up is that the email address has nothing, on the certificate has nothing to do with the company, which is really strange. And when you look at the domain, it's something that is related to Apple iCloud accounts from back at 2012. If you opened an account before that, you got a few other domains with it. So it has nothing that seems even relevant to the files. We continue on looking at the company. We wanted to see maybe somebody tried to kind of play with us and use the real company, or maybe the company was fake. So we couldn't find any reference to the entities that we talked about, Packety LLC and the secure network stacks that is in signature. There were no profiles of employees online, which is kind of funny because Lee was supposed to be the CTO. You'd expect somebody like that to have some presence online. And the site was up for 2 years, which is quite a lot of time if somebody wants to create himself a cover story and just keep it running and then use it after such amount of time. In addition to the website, they also had a Twitter account. It wasn't very active. There was some user reviews for the product on Google, which weren't really that positive when we think about it. And the code signing certificates themselves, well, to get a certificate, you usually have to pay to someone. But those specific certificates were without extended validation, means they are cheaper, and usually getting them is much more easier and don't require any more complicated authentication by the certificate authority. So at this point, we weren't sure if we were at a dead end. We start reversing the binary, the Go executable that we got. It didn't look like a real installer at any way. Didn't add the UI, didn't create any files. It did register itself as a service. And it could update itself during its runtime. And the famous bandwidth sharing functionality, it didn't add anything like that. So we just couldn't see anything really malicious, but still not something that we could ignore, but not something that really screams at us danger. So we decided to keep on digging. We had two ways that we could go from here. One was trying to figure out the timeline and when stuff changed, and go back and find original installers, like all the original installers, and try and look for other files that are similar to the one that we got on the email. Doing it was pretty easy. You could use the certificate, the icon, the strings, few quick searches and queries on VirusTotal, and in our internal systems, we got a few hits. We found an older installer, older official installer. We can see that it was a different certificate with a different validity period, and the email was relevant to the company. So that really kept us going. When we tried to look for new files, as we said, similar to one that we got, the one we got, we found a binary that's called nethelper.gui.exe, which was signed with a similar with the same certificate as the file that we were sent, and the size was nearly identical. When we bin diff them, both of the files, we saw that they matched pretty almost completely. This one was first seen in the wild 2 days after we got the email. And when we diffed them, when we looked at the specific code changes, this is a graph disassembly of the main function. We can see on the lower right that there is a few new basic blocks. So what we did is when we ran it, we saw the flow that happens. So first of all, it checks if a service is not installed, and in case it isn't, it's the first time it's being executed, it will call a function that will download and execute another executable named prograpper.exe, which we'll talk about in just a bit. And then it will go ahead to install itself as a service and restart it as a service. What the service will do is when it will start, the main function will run. It registers a timer. Every 5 minutes, it will check for an update. This update is being done using an open source library. As mentioned previously, Go has a very significant open source ecosystem. And if the update is available, thank you. Give it up to the team. And when the update is available, it will simply fetch it and restart itself. So the tools that we found, we named them NetBounce. We'll see why in a second, just why. So the self-update capability that we mentioned is using the Equinox package. It's both an SDK and a public paid service, meaning that they offer the ability for you to pay them, and then they will host you, and you pretty much don't have to deal with all the logistics of the updates. And they also have a pretty good documentation, and that code we found it copy-pasted inside of the malware, pretty much without changes. And we can see that on the left of the screen, we can see the authors took the code as is and didn't change it a bit. And on the right, this is post-update. They changed the package name, alongside changing the default values for the download URL and the user agent. Another change was that on the first stage, the pre-update version had hard-coded app ID, while following the update, they changed to an app ID that is generated by the machine serial number. So another capability that we found was the reverse proxy. This capability was in the post-update sample. Maybe you could think that it's the promised bandwidth sharing functionality, but at least it's partially true. You just won't get any money out of it. You also used another open source from Go, the tunnel package, and it was also changed slightly, just in order to allow the attackers to decide on where they can redirect the traffic. The package by default does the redirection only locally, only on the localhost. So you can see that the formatting is just slightly different. So just to recap for a second, we had two stages, the pre-update and post-update. The pre-update can lead to an execution of a different program. It's called prog-wrapper. We'll talk about it in a second. It has a persistency for itself, and the update that is redirected to Equinox. And post-update, the updates goes through the net bounds domain. So what is the prog-wrapper? We ask ourselves if we reached an actual payload, because like up until now it was only the delivery phase. So no, not entirely, but it was also signed with the same certificate, the same faked certificate. It basically also downloads and executes another program, but it does some basic check before that. It fetches some sort of configuration. It checks whether a file or a registry key exists on the machine beforehand, and if not, then it will download it and execute it. So the payload that we got, the output 40.exe, turned out to be an info stealer. It was packed with a few layers that also seem to be related to this malware infrastructure, malware delivery infrastructure. The payload that we saw was Figure Stealer, that at the time was relatively new. It was less than 6 months old. Reports link it mainly to Hansitor. Its developer, it's sold in Russian hacking forums, and its developer actually handed it out for a review. You can find it online. It's very funny to see. Google Translate does a really good job on that. It's written in Rust. Up until now, most of the files were developed in Go, but this one is in Rust. And it also added, eventually also has its own download and execute capability. And one other thing that is interesting is that we can see the tracking folder, start.txt. This is the actual first operation that happens in this variant of the Figure Stealer. We went back and for previous variants, it wasn't there. If we go back for a second, this is a similar path to what we get from the configuration of the downloader. So it's another interesting link between them. So at this point, we did this cycle a few times more, and every time we got a new piece of information, we chased it. We also found support for cross-platform and variants for Mac, which we found via hunting. It used the same app ID and similar URLs for download. Basically, we found an app package with a post-installation script that fetches the first stage variant, and then executes it. We also find a Linux sample, few actually, and here we did a nicer trick. Basically, since the updating capability is implemented by the same Equinox SDK, we kind of figure out how the links to the binaries on the server looks like. We relied on the fact that if the client is Equinox, the server side might be Equinox as well. And we started figuring out all the details that it sends on the protocol and how it builds the URL to download the file. So basically uses the name of the executable with the version, OS, and the bitness, the architecture. And then we just started messing with it until we managed to fetch samples from the server, from the netbound server. The infection vector we found to be from zip archives and MSI installers, which makes sense because that's the first time when the first time the pre-update stage 1 variants are being executed, the service is not installed yet, so it will also do the download and execute, the extra download and execute of the program wrapper. They also had program wrapper in the stage 1, also in the stage 1 variant, also had shared code. The same download and execute function was pretty much the same. And we got other payloads. We also found a program wrapper variant with a reverse shell, a mini backdoor if you want. It added the command functionality. And for some reason, it decided to use the NetBounce user agent. We also capture more info stealers, such as the Vider stealer, and the other variants of the packer that basically worked a bit differently, but the layers were pretty similar. So if I just have to recap for a second, now when we have the entire picture, all what we see circled in red is what we call the NetBounce toolset, which is pretty complex operation. The C2 infrastructure that we saw, I'll go a bit about it pretty quickly. Many of the domains were registered by the same entity, even though it was private. You can still see it's the same account that did that. Subdomains are the same, and some use the same subdomain, and some use the same, very similar distinct pattern, even though it's not really, let's say, complicated. All the domains were resolved to the same IPs on the same subnet, and some different domains also pointed to the same servers, the same IP addresses. We could also see, and when we looked on passive DNS data, we can see the lifetime of the campaign. We got the email on the 12th, and pretty soon after, we could see that the threat actor decided to start changing the domains, maybe because we didn't respond to their call. And here our investigation ended. We decided that that's it, and we could move on to our next thing. Our conclusions were that the sample that they sent us, that they pointed us at, is sterilized, stage 2, post-update. It had the NetBounce version of the update mechanism, no program wrapper, no download and execute, and no reverse proxy. So maybe it will be a bit less suspicious. And they did it in order to trick us, and so we could whitelist them, and not in order to infect us. And their end goal is using smash and grab stealers, such as Ficker and Vider. So just to wrap up, basically, they were very confident that the threat actor here was very confident with their, let's say, cover story tooling, and they decided to try and use it directly against a security vendor with social engineering. Maybe if you can't beat them, then ask them nicely to let you go. We saw a pretty complex multistage infection mechanism. It can be activated at any point in time, and it even after it works for the first time, it stays there and they can reuse it again and again. Since all the tools were written in Go, it was really, really helpful. It was, at least for the attackers, it really cut down of the work time. And they only needed to use like open source that had all the functionality that they need with really minimalistic changes to support the different operating system. They only had to switch the compilation target, and that's pretty much it. Almost, just almost. I have to admit that when I prepared the slides for this talk, I was a bit bummed down. I started working on it, and I saw that basically I'm going to do a talk about the malware infrastructure that is 6 months old and is not very active anymore. But apparently, up until this week, I was wrong. Introducing Mosaic Loader. So the day before last, Bitdefender published a report about it. It looks really similar to ours. It shares the same infrastructure, same TTPs, same installer theme. Signed binaries look the same, multistage infection mechanism, and the same program wrapper. It's pretty much all the same code. And yeah, as I mentioned, it shares the domain and IPs. It also delivers info stealers. It basically seems like a port to Delphi. So when we looked about it, I looked at it very briefly, and it seems that like 3 weeks after we published our work, the attackers switched and this new campaign began. So it's interesting to see that they're still active. Any questions? Thank you.
Thank you so much.